Okay, AP Chemistry, back again. So now we're on page 3 of the covalent bonding notes, and this time it's still talking about hybridization. We went over an sp2 hybridization, what that kind of looks like, and the bonds and what's happening. So now we're going to go over an sp. So an sp is going to be a couple of different options, but essentially it's a linear molecule. It only has 2 bonding sites, S and P, 2 different letters, and so it's going to be 2 different sites. And that's it, 2 different orbitals formed. And so we have right here is essentially ethene was the last one, ethine, which would be a triple bond between the carbons. And because of that, there's the hydrogen on the other side, so I only have 2 bonding sites on this carbon, and I only have 2 bonding sites on this carbon. So that means both of them have an sp orbital. This will be the first orbital, this will be the other orbital, the sp orbital, so to speak. And then carbon dioxide would be right here, and the same thing. It's only double bonds, but that carbon has only 2 bonding sites because it's double bond on both sides. And so therefore we're taking up all those electrons in just 2 bonding sites. So that's what it's talking about. And then it shows you the hybridization, and it talks about it. So sp hybridization on both those parts. And then the P's that are left over are what are going around. So for the ethine, it has 2 unbonded p orbitals, or unhybridized, not unbonded, they're bonded, they form the double and triple bond, but they're unhybridized, and they're reaching around that sigma bond to connect with each other. The molecule reserves 2 sets of unhybridized p's to form the 2 pi bonds, which is what I just said. And then hopefully everything's making sense. It draws the pictures. Again, if you look at those pictures, hopefully you can kind of get a feel for what it's talking about. And the carbon dioxide molecule is also drawn at the very bottom, and it shows you the pi bond as well for both of those. And so that carbon's 2 p orbitals, one is going to one pi bond, the other one's going to the other pi bond, but they're still going to the pi bonds. It's still 2 p orbitals that are unhybridized, essentially. And yeah, remember that double bonds have a higher electron density, and so they're going to be closer together. And then underneath that is a table, and it's hybridization to try to help you kind of see what bonds would form what hybridized sets in the geometry. So if you have a linear one, if you look at the first one, a linear one, that means you only have 2 bonding sites, and so the number of hybrid orbitals would only be 2. You'd have 2 of those. Just like this has 2 right here, kind of thing. And this has 2 different hybrid orbitals, that's it. And it would be an S and P, and then the next one would be sp2. So remember, you're thinking about those bonding sites, and that's your geometry, and that's your electron geometry, not your molecular geometry. The electrons are all tied up in those bonds in this case. So yes, this is a linear electrical structure, and it's also a linear molecular geometry as well. But not always is that the case. Like ammonia would be a tetrahedral, even though the molecular shape would be a trigonal pyramidal. Oh my goodness. So make sure you understand the difference in those. If you're not, shoot me a message. I can do a video explaining those again. It is also in my previous video explaining the difference in the 2, probably like 3 videos ago, and it's in the last bonding notes towards the end, one of my last 2-3 videos. So you can go back and look at those, or you can shoot me a message and I will respond as quickly as I can. That brings us to the bottom of page 3. If you want to look down there at like 5 and 6, that's whenever D's start to come in. So you see that pattern where the 5 would be the DSP3, and then you have a D2SP3. And it has pictures down below to try to help you follow along with those hybridizations. If you can download the notes online, the color helps you see and distinguish the bonds a little bit better and the 3D shapes. So that would be my recommendation, is to look at them online through Google Classroom. If we keep going to page 4, it is laying it out for you again. It's just doing better pictures. So they're tiny, but in the notes you can like zoom in and see them. And so it's trying to show you those shapes and the bond angles and the hybridization, so you can kind of see what's happening there. And then it has benzene, which a benzene ring would be it alternates double bonds. So like it's going to be a double bond, single bond, double bond, single bond, double bond, single bond. And so it's rotating. It's 6 carbons bonded together. It's in your organic notes. Benzene is a very common organic sample, but if you don't remember that, you can bust out your organic notes, or you can just look at this and see if it makes sense, and kind of see what's going on there as far as the hybridization goes. And so then you have your sigma bonds, and then you have pi bonds around that as well. And don't forget about resonance. So it's wanting you to draw that structure. I don't feel like there's too much else to talk about here. If you feel that there is, please, again, send me a message. I want to make sure y'all are understanding this. Remote learning is tricky. And then we go on to page 5, and page 5 is examples, exercises. It wants you to describe the bonding in the ammonia molecule, which I already talked about with you, localized electron model, and so the different things that you need to touch on. And so see if you can go through those exercises. It's a whole page of exercises. And if you get stuck, again, please message me, and I can always upload the answers or answer your question directly. So I'm at 6 minutes, so on my next video, I'll pick up with page 6.